Alright, let's deal with number 3. Alright, so what's going on with zinc iodide? Well, here's the reaction. Alright, and what we do is, what we remember is, let's find the oxidation numbers to figure out what the heck's going on. Zinc metal by itself, 0. Iodine by itself, 0. Remember, it's a Brinkelhoff and it's an elemental form. Iodine as an ion is -1. And since this is -2, and the sum has to equal 0 because there's no charge here, this has to be +2. So what we see here is that zinc is going from here to here. It is losing electrons from 0 to +2, less oxidation, because it's losing negative electrons. And iodine is going from 0 to -1. So it's gaining those electrons. So basically zinc is giving its electrons to iodine. And we know that because if we were to think of it in terms of Lewis dots, we know that zinc and iodine, this is the way they are. They're all bonded, everyone's happy. Zinc gives one electron to one of these iodines and another one to the other one. And that forms Zn2+ and 2 of these iodide anions, and they stick together to form an ionic compound, ZnI2, when there's no water. And this is the white stuff that you found at the end, because it's the combination of the zinc ion and the iodide anions. And these things are usually clear in solution, and then most ionic compounds are white when they're evaporated. So here you go. If you wanted to think about the reasoning, these iodine atoms, they're bound to their twin sister here, and they would rather have the electrons to themselves. They'll share if they have to. Remember, this is a covalent bond. But these both they're both, the key word really is electronegative. I don't know if we really talked much about it, but each one of these iodines wants the electrons for themselves. They'll be fine sharing it, but when given an opportunity, they'll take the electrons for themselves. So zinc doesn't really want those electrons because it's stable, and iodine wants those, so it'll take it. So it's like a give and take relationship. It's very nice. If you were to do the electron configuration, I don't have my periodic table, you'll see that this is has the same electron configuration as a noble gas. I think it's krypton. Anyway, look it up, you'll find it. Well, hopefully this helps. Good luck.